Welcome to the Internet of Things equation, a podcast when I talk about the Internet of Things domain both from the technical and business perspectives. I'm Łukasz Malinowski, the Internet of Things advisor and trainer. Today I have a great pleasure to meet with Dominik, the CTO and co-founder of HiveMQ. Dominik started the HiveMQ, a respected MQTT platform, over 12 years ago. So for sure, he has tons of experience to share with us. Hello, Dominik. Thank you so much for accepting my invitation.
Absolutely, Lukasz. Looking forward to the conversation.
So you are a well-known figure in the IoT domain, but for people outside of our little niche, could you give us a bit background of who you are and what was your IoT journey?
Oh, absolutely. My name is Dominik Obermaier. I am the CTO and one of the founders at HiveMQ. We are an enterprise MQTT platform, and we serve especially Fortune 500 customers across the world, from big automotive companies, as an example. Most of the cars in the world, actually, that are either produced or while you drive it, they use HiveMQ, either in the production process or in the process of you driving it. But we also do a lot of work with energy companies, the biggest energy companies in the world, connecting their remote assets. We work with oil and gas companies, also renewables. We also work in the medical domain a lot these days, a lot in manufacturing, discrete and process manufacturing, and of course, a lot of connected devices, which is one of the origins of IoT. I spent in the last 12 years working on a technology called MQTT. I worked on a company that's built a business around that communication protocol at the end of the day. It's really fantastic to see how things unfolded in the last decade. So when I started working on the MQTT specification together with a few other folks in 2014, we released an MQTT version 3.1.1, which was for a very long time the default for all IoT communication until 2018, when also we, and also I personally, together with many folks, for example, also at Microsoft, Cisco, and others, standardized on MQTT version 5, which is the new standard, which is already 6 years old, which is like a long time, of course, in the IT business. In the meanwhile, I also wrote a book on the foundations of IoT, which is used in universities, and together with some other brilliant gentlemen, and we created a book for students from atoms to big data platforms and everything in between. I spent also these days a lot of my time, my career, talking to customers, understanding how IoT is disrupting every industry. And I hope we can talk about this also today. But first of all, to start with a almost provocative statement, I do not believe IoT is a market. IoT is really like a characteristic in all of the markets. And what we at HiveMQ here believe, we believe that every company is an IoT company, similar to every company is a computer company, a computer business. And also every company these days relies on the internet. Every company is an internet business. And we truly believe that every company is or will be an IoT company without even knowing. They will probably never use the word IoT, but all of the characteristics that connecting machines and humans together will create overall greater business value over time. This is one of the core beliefs we have here.
Let me jump in. I hate to say that, but I do not agree with your core belief, and I don't agree that every company is IoT company. I know what you mean by that, but from my perspective, very few companies in the world are actually IoT company, and HiveMQ is one of them. But as you mentioned, IoT is just technical capability. It's not a market. It's not even a domain. It's just a capability, and we can provide business value on top of that capability. On that, I totally agree, and we will dive into that later today. What is important is the business value that we generate, not the technology that we use in the process. But speaking about technology, there is one question I need to ask you. What is so special about MQTT protocol that you decided to build company around it?
Yeah, so one of the realizations that we had back then, and remember in 2012, IoT was not really a big word back then. A lot of people were reusing machine-to-machine communication as a term for also connecting devices over the internet and so on. I remember Forrester and Gartner when they came around and predicted big numbers of connections, like 50 billion connections by 2025. Then IDC later came and said, you know what, it's actually 70 billion by 2025. But overall, people agreed on that there is a huge exponential curve of connectivity going on. They argue there is, different dynamics going on. There was a lot of arguments around Moore's law. This means Compute is getting cheaper over time, energy is getting cheaper over time, connectivity technology is getting better over time, and so on. And so a lot of these ingredients of the perfect storm were quoted as a reason why we will see this hyperconnectivity going forward, which turns out people were quite right. I think just the timelines were sometimes a bit too aggressive for some of the predictions. But we were wondering back then, and so we found us, we worked at a company and we were running in basically applications. Like I have a bit of an operations background, but also software development and architecture background. And we had applications for humans when we had hundreds of thousands of users. Like everything was under stress. Like pretty much the databases went into problems. Like a lot of scalability problems emerged there. And we were wondering if the technologies we use for humans today, if we apply them to the challenges for the Internet of Things, how would that work? We don't see it. And then we found it also one of the core beliefs that the technology required for creating the Internet of Humans is a different one than you need for the Internet of Things. We were wondering, how would you do that? To make a very long story very short, I found myself on my way to Kansas City, where I met, by coincidence, Arl Nipper, who's one of the creators of a protocol called MQTT that was invented in 1999. And then it dawned on me, this is the solution. Like this is the real solution for all of this. But the MQTT protocol has a few challenges that need to be addressed. First of all, it's not a standardized protocol, which then also we help work on to fix this problem. But there's a lot of technological issues because MQTT is inherently and absolutely hard to implement on the server side. It's extremely easy to implement on the client side, but the server side is really, really hard. And you see even today that most MQTT providers don't even fully support the full specification of what the MQTT protocol asks for. Especially the non-optional features are usually not supported. And the reason for that is because it's really, really, really hard to do this at scale. And this is what we spend a lot of time the last 12 years on to work on this and actually solve these issues. And we discovered also 5 other issues that needs to be added to the MQTT protocol to make it viable for businesses. And all of these we are providing on top of our MQTT platform. But overall, just to finish this thought, also, I always had the core belief, and I still believe this to this day, that communication technology needs to be open. And the biggest mistake that I've seen also in the messaging world in general, but also when it comes to IoT technologies in the recent years, is many companies try to push for proprietary specification of standard. And I see why you would do this as a business, because you have absolute lock-in for your customers. But the problem is, if you are going into the value chain of your customers don't want to lock in, and you shouldn't lock them in. You should lock them in by providing additional value, but not by technology choices. And fortunately, the world moved on from this, and now MQTT is the standard protocol for all IoT communication. Only a few niche use cases use something else than MQTT, but pretty much everybody settled on this debate, which was not settled 10 years ago, but these days, chances are, if you're using either any proprietary platform or any open connectivity technology on the application layer, chances is that MQTT is being used somewhere.
One of the huge potentials provided by MQTT is that many-to-many communication. And that is the core of the IoT as the ecosystem of applications, devices, and users working together to deliver business value. That's why, personally, I'm also a huge fan of MQTT for exactly that reason. But you mentioned something very, very important, that the MQTT broker, the backend side of that IoT communication, this is a tricky piece to implement right, because essentially what it is that is the single point of failure for the whole ecosystem. So you're a technical person, could you give us some hints how to implement the MQTT broker right to avoid that one thing that can go wrong and everyone is offline?
Yeah, absolutely. So for the people who are not familiar with the MQTT protocol, so the MQTT protocol, as you mentioned, it provides a single endpoint for all of the devices that you're exposing. And the benefit of that is you're decoupling the producers from the consumers. And you also mentioned the fact that, for example, a device can create some kind of data, which could be, in a trivial case, a temperature reading, or could be something very complex, like if you have a car and then you're creating some usage metrics that you need for whatever reason on the back end. Could be because we have some use cases that pay into some real business value. For example, there is insurances these days who do calculations on the fly based on your driving behavior, as an example. So the value of the data produced could be very different. Could be something trivial, like telemetry data, or could be something with a real business value. But in any case, the producer of the data doesn't need to know anything about what's happening with the data. So because the MQTT broker, which is the heart of the communication, it allows an almost virtually unlimited amount of connections. We can talk about the technical limitations there, of different consumers also. So a single data point produced by, say, a car that is sent to the broker can be multiplied to whatever, literally thousands or millions even of consumers. The reality is most of the use cases only have a few consumers, so like a few backend applications. But overall, you can also use the MQTT technology to notify all of the cars in Germany that there's a firmware update available. So you would send one message from the backend to the broker, and the broker would distribute it to, say, 5 million cars. And this is, I think, the beauty of it. And it's so different to any messaging technology that has been used for the last 30 years or 40 years. And the reason for that is, while it's PubSub, and PubSub is nothing new. It's an architecture pattern that is an enterprise messaging. Is a traditional pattern that even in the beginning of the 2000s was getting really, really popular. But what's different is that you have these large amount of producers and consumers at the same time, all with specific requirements like low latency, insane amount of data being produced, much more than with traditional messaging. So we literally talk about, in a typical IoT deployment, like hundreds of thousands of data points being produced per second that need to be distributed, or even more. And like all of this together makes it really, really hard. And what makes MQTT so great for connected devices is, if you have moving devices, a car is a perfect example. Usually what's happening is the connect is not always in the same quality. So what can happen is, I mean, I live here in Germany, and in Germany, so the people who not live in Germany, you would assume we have a really good coverage when it comes to mobile technology, which we do not, by the way. So if I drive out of my house here, there's nothing. Like I have a black hole pretty much for a kilometer or so until I get connectivity again. The cool thing is now all of the hard things to implement, like offline buffering, what retry mechanism, making sure data points are sent at least once or exactly once, and so on. All of this is done by the MQTT protocol. So, example, if I drive out of my garage here, it loses connection to my Wi-Fi. So data is still being produced in my car, but cannot be sent to the cloud because there's no connectivity there. And once connectivity is back again, it will resume as nothing would have happened. So the only service degradation you would see is longer latency, but this is like just a law of physics you cannot beat. And this makes it so easy, but the server side has real troubles because the server side takes care of all of this. And we have a virtually unlimited amount of topic namespace. This means while in traditional messaging, you usually define the topics for your PubSub beforehand. So you have a few handful of them or hundreds or so. With MQTT, you usually have per device multiple topics. So we have customers that have literally more than 300 million topics in the same installation. And this makes it a very different beast to implement. And a big mistake that many companies do that also offer MQTT support is they build MQTT support based on existing technologies. And I think the right way to build an MQTT broker is start from scratch and build it purpose-built. And it's very hard also to bring in other messaging technologies because it's just the exact opposite how it works compared to other messaging technologies.
That was a deep dive into the technical side, but operating IoT at massive scale is an even bigger challenge on the business and operational side. You work with C-level executives that are introducing the digital transformation using IoT, and MQTT is core part of the IoT technology. So could you give us some examples of operating IoT at massive scale, but from the business perspective? How does it look like?
Yes, it's an interesting one. First of all, I think what's really important is to differentiate also the applications of IoT. So connected devices, which is what most people think of IoT, and I want to talk about this, is very different to say industrial IoT use cases because just the characteristics are so different. So let's focus on the connected devices use case, what most people believe what IoT is. And also let's make the connected devices use case where you actually have customers who sell physical things also to their customers, which is a very traditional use case. So there's, I think, at least 3 business challenges I want to talk about. And all of them are important and many of them are not well understood. And unfortunately, I saw many IoT projects fail also in the past because these things were not really considered beforehand. And this has nothing to do with technology. It's really just business. Number one is connected devices. If you're in the connected devices domain, this is super tough. The reason for that is because a connected devices business, in order to succeed with IoT technologies, there's, I think, 2 paths one need to go. Either you have a very high margin product, so the recurring cost of IoT connectivity will not make a big difference. For example, you have cars or other things, and the more premium you are, the better. This is also true for many premium consumer devices. But if you are in a low margin consumer device market, this is a really tough spot to be in. If you do not have a subscription model, it's the second thing. You either have a high margin product or you have a subscription model. Depends on the market you're in. I mean, we have this kind of planned obsolescence thing going on these days, that after a few years stuff breaks down anyways. I'm not a big fan of this very personally. So if you assume you're building something for consumers and you want to support it for the next 10 years, you need to, besides the initial costs, you need to think of the recurring costs every year. And this can be at scale really, really huge, which brings me to my second problem. There's a trap that many companies fall into and also fall into these days. And this is the IoT platform trap. And there's two problems here with IoT platforms. So problem number one, IoT platforms are actually not a platform. And if you take the classic definition of a platform is the Bill Gates definition. And he said a platform is where the economic value of everybody using it exceeds the value of the company creating the platform. This is the classic platform example. This is not true for most IoT platforms. And the reason of that is because they're actually not platforms. I mean, if you look at other platforms these days, they're popular like Kubernetes. This is a platform. The definition of Bill Gates applies to here. Also, if you go to whatever the Java Enterprise Application Servers back then, which was also a platform, apply to this. Windows or operating systems as platforms, they work with this example. Also, some platform as a PaaS offerings, like platform as a service, Heroku and others, or EC2 or these kind of things, they also apply to this. But IoT platforms are only toolboxes. And unfortunately, not even very good toolboxes most of the time. So sometimes I recently had a conversation with somebody about this exact same topic, and they said, you know what, my father gifted me some time back when I moved out of the house, from parents' house, a small toolbox with everything in there. The problem is, all the tools are in there don't really work once you use them seriously. And so this person rebought most of the tools frequently used because the toolbox had okayish tools, but they weren't really purpose built. And the same is true for IoT platforms these days. And we saw that, I think a few years ago, we had more than 500 IoT platforms out there. I don't know what the current number is, but the consolidation in the market was just crazy, and it's still happening. And many people also pulled out of the IoT business. Think of Google, GCP, they moved out of that. We had SAP move out of it. There is now a lot of, let's say, word on the street that other big players are thinking of moving out more and more of the IoT business. So this is tough. It's really, really tough because it actually doesn't provide the value to customers what they were achieving because they're not platforms. So this is problem number one. The second problem is the economies don't really work out. So most of the IoT platforms start super cheap. So you can get a POC running with your personal credit card because frankly, this doesn't make any sense even to talk to your boss to get some budget approved because it's just so cheap. So with a few cents or even dollars, euros per month, you can get going and build a prototype. Usually, if you sell devices, and most companies are really good, if you sell physical devices, you usually have a business model where economies of scale apply. This means you're taking advantage of your supply chain, you're taking advantage of also other economies of scale things in IT, as an example. If you have a server, for example, you buy a server yourself, it's a one-time cost, and then the more workload you can put on it, the cheaper the workloads get overall, and so on. If you look at the classic IoT platforms, they do not allow you to go into economies of scale thing. I mean, you get a few discounts, but not to that extent that you get with other economies of scale dynamics. And so what's happening is you can almost in a linear fashion say how much stuff costs. And then even worse, the thing is then there is a lot of hidden costs also, because then first of all, you connect things, then you process things, which there's some services that cost money in addition. Then you move the data from this service to this service, which is more traffic cost, and so on. And it's very, very hard to predict the actual cost that you will have beforehand with most of the IoT platforms out there. There are some alternatives, by the way. There are IoT platforms that give you, let's say, value-based pricing. If you want a generic one, there are these kind of players, and they work really well. We also see IoT platforms that are really purpose-built for one specific use case, like Samsara as an example, which is, I think, technically many people would consider them as an IoT platform, but you can't use it for some generic things. But they're really purpose-built for one domain. There are niches out there, but the generic IoT toolset is a trap. And most of the project I saw failing is because of this, because the realization was later, oh man, actually, we don't get what we wanted, and costs are not what we expected, and so it's getting uneconomical. We can't unlock economies of scale, and so projects get cancelled because also the user, very often the features built on that don't justify the investment.
That's a great point that you brought about the economy, that the costs of operating IoT can get out of hands really quickly. And the point that you made about those devices is that if you offer a connected device, essentially you earn when you sell it, but then you're losing money to keep it operational. You pay for the connectivity, you pay for support, for the backend to get that data. So
Yeah.
this is extremely important for anyone listening thinking about starting IoT-enabled business, that
Mhm.
they should consider those two options Dominik mentioned. First is go premium, so those costs are kind of included into the initial price, or
Yeah.
use subscription, so customer participates in the operational costs generated by device owned by that
Exactly.
specific person. That's super super important. I would like to make one more comment because I love your example of IoT platform as a toolbox. And actually, there are two things that I want to mention. First is you need to be educated enough to use those tools from your toolbox. I've got lots of tools that I cannot use myself, for instance. So, in my
Yeah.
opinion, this is not fair to push that to the customer. So, dear customer, this is my premium toolbox. All of those tools are top quality, and it's up to you how to use it. And this is the approach that the hyperscalers are using, in my opinion, because I've got some experience in working with those
Mhm.
companies, that they give you tools, but security and keeping the whole thing operational is on your end, Mr. Customer. So how do you handle that from your perspective when you work with customers, when you cooperate with them to build huge IoT deployments? How can you help people that are experts in their domains, but they are not experts in IoT and such?
Yeah, yeah. Which is also clarified. So what we're doing, HiveMQ is not an IoT platform, as what we are doing here in the business. So most of the customers we have, they take a best of breed approach. So they know exactly what kind of problem they want to solve, and they're using the right tools for that. And they also know there is no silver bullet, one size fits all, but it needs to be adapted to their domain. And most of our customers understand that what they're doing here with us is actually getting core business. This means we're either somewhere in the value chain. As an example, if you produce a car, this is definitely a value chain. So we are in there. But also if we have in the energy sector, if you have remote assets to be monitored, this is value chain, because if your remote assets cannot be monitored for energy creation, depending on how big you are, this even can lead to some investigations by government. The stakes are pretty high here. And so there's like an actual value to be unlocked. And we also do some connected devices use cases, but this is more, for example, we have a self-service cloud and so on. That is a bit more generic. But the customers we work with, either they already have a very clear understanding on the value they want to unlock, but also we help them very often. So because sometimes you have the case where people, especially as executives, they learn, okay, other companies are getting much more value. The digitalization projects are much further than in their own company. And so they usually ask, and also vendors to say, okay, educate me basically what we are missing, like what value don't we see currently that other companies do see. And because there's competitive pressure these days, if you're missing out here, and especially in the manufacturing space, in the industrial IoT space, these days we do a lot here because everybody's using something called unified namespace as an architecture pattern. And I mean, Gartner also recently published a report where they strongly recommend also the unified namespace as an architecture. And this is completely built on MQTT. So for in the factories, but also for connecting the factories. And so we do a lot of work these days around this, and also help the customer understand like what are they missing out, and also what is the competition doing, and how is the competition producing more in less time, or is bridging also some operations and IT technologies gap. Here at HiveMQ, we work extremely close with the customer. We are not a project-based business, so we're not consultants. While we do have extremely awesome professional services department with, I think, one of the leading experts in IoT technologies, but we usually bring them in not for consulting projects, but for really helping the customer if there's really deep technical or massive scale questions to be answered there. And we work with a lot of partners. Usually our partners build the overall solution. We are part of HiveMQ is part of a solution. HiveMQ is not the solution. And this is important because every customer is very different and has different needs. We're not the one size fits all thing. We don't want to be that. But what we're building is the central nervous system for all of these customers, for moving the data, making sure the data is correct, and modifying the data, transforming data, and all of that. So really making sure that the data channel and the data pipelines are there, what they need. One thing I want to mention on your previous question, because I said there's three things, I forget to mention one thing that we also see, by the way, a lot. And there's something called Conway's law in computer science. It's actually an organizational theory. And Conway's law pretty much says you're always shipping your org chart. And what it also means is the software architecture you create is based on the architecture of your organization. And a big problem we saw over the years a lot is that the people building physical things that you sell and the people building, for example, the cloud backends, there sometimes, if you go up in the chain, they're in very different departments, sometimes up to the CEO. There is nobody crossing them. There's different VPs and others, and there's nobody in between. Because like the domain, in a car example, the domain of building software inside the car is completely different, in a different ballgame than building cloud software. And like from a philosophy standpoint, from everything. And these people usually don't talk a lot with each other. What we saw is how companies solved that is they reorganized their company also to some extent that they understand, okay, there's a void. And then you either build a team bridging that, so a kind of bridging team, or some companies go and say, you know what, guys, you're one product team now. And then they move it out to different departments. Some even pull it out into different companies even in order to make it very clear. And we saw this being successful. Currently these days in manufacturing, we see a lot of operations technology and information technology gaps there for the same reason. It's all Conway's law. And a technology like MQTT cannot solve the problem, or a messaging technology in general. But what it does, it shows you the breaking points. It shows you these people don't talk to each other necessarily. And you can either try to band-aid this with technology, like you're enforcing schemas, you're enforcing specific things, or even better, you help the customer understand, okay, there's something here that even whatever deserves a new team or deserves a reorganization. And this is actually what's happening for most companies after they understand, man, digitization is more than just adding additional features on top of it. It's actually an organizational problem and not a technology problem.
Totally. The digital transformation, this is the transformation of the business and the way the business operates and delivers value. And what you said is extremely true. And this is what I see from my own experience, that when I help some companies to transform, to leverage IoT to provide better value to the end customers, we often sit to the table with different departments with the same company, and those people do not speak the same language. They do not even cooperate. It's not like they do not know each other, but there is no information flow, and everyone is focused very much on their own KPIs, not on the end-to-end way to deliver value. So this is very, very true. And actually, in those cases, we can use technology as an excuse to make those people actually to cooperate with each other. At the end of the day, we will provide our fancy IoT devices or backend or application, but it is not the true value of transforming enterprises. So I absolutely agree with what you are saying. So how has the IoT market evolved over those 12 years? Because you mentioned that there are predictions regarding number of connected devices, and those predictions, at least from my perspective, are lagging a bit behind. Like reality is not that easy, but you are hands down daily with huge IoT deployments. How has the IoT landscape evolved over those 12 years?
It evolved very interesting and in different ways than I would have expected. So in the beginning, I was thinking a lot about connected device use cases, because these are just the obvious ones. Connect everything in your household to the internet, like it just makes sense. I still think it will happen, but I think it will take longer than people anticipate because of, and we talk about this, it's very hard to unlock the value there. And I mean, things are getting cheaper also on the hardware level, but also on the connectivity level. A few things in the macroeconomics changed a lot. For example, we now have major rollouts of low power wide area networks these days, which we didn't have so much 10 years ago. So even if you're in the US, if you're in Europe, chances are very high that you have good coverage with things like narrowband IoT. You have also chances that whatever LTE-M or other things are there. And not so much with 5G, but also 5G on the other hand also is there. So we now got from the, let's say, typical 3G, 4G networks you get everywhere, we went into, okay, we have super high bandwidth, low latency things, but with not a lot of reach from mobile connectivity standpoint in cities and so on, which is 5G. But on the other hand, we have this low power wide area network things that cover a lot of area, but they do not offer low latency or high bandwidth. So exactly the opposite. They're super slow and it's really hard to push data across these channels. And then, of course, also everything in the middle just got more stable and better, except in front of my house, but this is a different story. and also the prices went down. So if you look at the data transmission prices, they were extremely high back then. They're still extremely high today for machine-to-machine communication. People would be surprised. I have a 30 gigabyte plan here per month on my phone. The machine-to-machine world, you would bankrupt if you do that, almost. Like it's really expensive stuff. Also, we have other developments like satellite communication is getting more ubiquitous. I do expect that there will also be more use cases where VSAT is getting cheaper based on things like Starlink, and there's like other providers who pretty much put satellites out into space a lot, which I also expect at some point of time will hit IoT deployments sooner or later, especially for the static ones. So overall, things get cheaper. This is awesome. This means stuff gets more connected. This definitely changed. Technologies changed a lot. Back then, we had things like CoAP, AMQ, XMPP, and so on for device connectivity. I mean, pretty much nobody's doing that these days anymore. And people have MQTT. But we now have that, by the way, one technology problem, which is, I talked about 5G and I talked about low power wide area networks like LoRaWAN and others, and narrowband IoT and things. On this end of the spectrum, most technologies are not good these days. Why? Because all of the internet is connected over TCP, which usually nobody cares about because it works well enough for almost everything except video streaming. But if you have low bandwidth or if you require really low latency, TCP gets into your way. This is where also technologies like MQTT SN, which is short for sensor networks, is now being standardized. And I think by end of the year, end of 2024, we will see the official specifications out there. We will see the first providers, including HiveMQ, supporting that. And they're designed for the ends of the spectrum I just mentioned. So while people might think, oh, there is no innovation going on there anymore, this is not true. There's a lot of innovation going on there for enabling even more use cases. And the good thing is completely compatible with MQTT. This also, I think, will mean that I expect technologies like CoAP and others also for these specialized use cases will go out more and more. People realized, so also Gartner has this nice hype cycle curve. And I think a few years back, we were at the top of the hype. Everything is IoT, everything's awesome, let's connect everything. And now I think we're in I forgot how they call it, but basically at the lower end of the curve, which is disappointment and so on. I think this is also not justified. But people came to the realization, you know what, actually it's really hard to make money with IoT. And this is where I see connected devices. If I look at industrial IoT, it's the complete opposite. Industrial IoT turns out there's an actual value there. There is a big, big problem because the unified namespace is, I think, by far the most radical and needed disruption that's happening in manufacturing since probably 40 years or so, since PLCs came around. And this is exciting for me. And we see companies investing big dollars in this area. We see actual value being unlocked after a few months even. We see the businesses completely transform based on unified namespace projects. This is why I'm really excited about that. Connected devices, as I said, is tough for multiple reasons. If companies figure out how to do that and what the value is, it's awesome. We have many customers there also, but most of the customers are more into verticals where they have a clear understanding of the value chain.
We are running out of time, but I need to ask you one final question. If you could share that openly, what was the biggest scale IoT deployment leveraging HiveMQ?
I think scale has two different dimensions that are interesting. One is the number of devices connected, and the other one is the data throughput. So with data throughput, so a single installation of HiveMQ at one specific customer is doing almost as much traffic as WhatsApp globally. But not with a lot of devices. I mean, still a lot of devices, but you're not talking about tens of millions, but less. We also have one customer in the automotive space, which has, I can't share the exact number, but it's below 50 million, but it's way above 10 million. So it's somewhere in the middle. And they have more than 300 million topics subscriptions on a single installation. They have hundreds of thousands of messages per second. They have multiple millions of queued messages at any point of time. They have hundreds of thousands of devices added a week actually to the deployment. So it scales also elastically up. So yeah, we run pretty big deployments with the customers. And what we sell at HiveMQ is reliability. I mean, you don't want to make sure that stuff is up and running. Like HiveMQ sells reliability. This is why we're in business. This is why we could grow, although the macroeconomics were not so good in the last few years for startups. We could grow. The company is now more than 200 people. We're growing like crazy. And also we are helping customers worldwide more and more. So every day, every month, we have more customers. We can help, and I'm very grateful for that. That many people are in a disappointment stage when it comes to connected devices. What we actually see is we work with the customers who either want to figure out how to provide value, or they have figured out how they can provide value to their business or to their customers. And this is exciting me. This might be probably for another conversation. I still believe that every company is an IoT company, but not because of technology, but because of the connectivity they provide. Because there is value to be unlocked. And I think what's really needed is there's more education needed in the market. And I'm completely with you, Lukas, when you say it's not about technology. Because it's not, it has never been. The tech business was never about technology. It was always about providing business. It's only just that sometimes technologists forget that in the end, everybody's in the business of making money and making their customers happy. And technology is a way for enabling customers. But it has always been about solving problems and not building technology.
Well, it should have been, but from my personal perspective and perspective of customers I used to work with, most of IoT POC projects failed because they were focused on technology purely. Because like people were playing with those shiny toys, and they were like everything got connected, LEDs were blinking, but there were no money printed because of those systems. And then the business stakeholders just take a look and say that doesn't do any good for us. We just want to shut it down. So I agree with you that we used to be at the hype cycle, the top of it. Now we are at the reality check. So the IoT needs just to work in the background, as you said. The IoT needs to provide complex solution. In order to do that, everyone should focus on their genius zone. In your case, this is the heart of communication, which is the MQTT broker. Other companies should provide what they are best at, and together they should create open ecosystem that actually delivers the business value to the end customers. Dominik, thank you so much for taking time to meeting with me today. It was a pleasure.
Thank you, Lukas.
Thank you for listening. Go to thefingers.com to find more materials about the Internet of Things domain. My name is Łukasz Malinowski, the Internet of Things advisor and trainer.